everyone. Thanks for joining us today to talk about security guardrails for AI applications. I'm Melinda Marks, Practice Director, Cybersecurity for Enterprise Strategy Group. As organizations are rushing to build AI applications that integrate enterprise and customer data with large language models or LLMs, we need to effectively mitigate security risks to reap the benefits, as the last thing we want is for a security issue to slow down adoption as organizations seek to leverage these new technologies. So we'll discuss how different AI architectures function, discuss the security risks and vulnerabilities they create, and review the best practices for mitigating these threats with strong security guardrails. I'm so thrilled to be here today with our guest speakers, Sourabh Satish, who's Chief Technology Officer and co-founder of Pangea. Hey there, Sourabh.
Hi, Melinda.
And Rob Truesdell, who's Chief Product Officer from Pangea.
Thanks for having me, Melinda. Can't wait to get into it.
Yeah, so we'll be taking questions at the end, time permitting, so feel free to enter your questions in the chat box. So to start off, our latest enterprise strategy research on GenAI adoption shows how organizations are currently using generative AI. Here we see 8% saying it's mature in production, 22% in early production, 33% in pilot or POC, and 9% in near-term plans. We also see organizations ramping up their GenAI usage. In the last 12 months, 45% said it significantly increased, 47% said it somewhat increased. So how are they using it? It's for areas including software development, research, IT ops, customer service, and product development. You can also see here the top benefits they are expecting here in this slide. So increasing productivity, increasing operational efficiency, improving and automating workflows, improving customer service, supporting data analytics and business intelligence. Rob, is this what you're seeing in the market?
Yeah, it definitely is. We have customer calls and prospect calls all of the time, helping people along these lines, and we're seeing exactly what you just outlined. Really, a combination of both internal and external use cases. External, mostly focused on improving customer experience and reducing friction in that user experience. But then on the internal side, making employees in the workforce more efficient for functions ranging from HR all the way to engineering and everything in between.
Our research also showed that when asked about top risk concerns for using GenAI, data privacy and security topped the list. Our research also showed sentiment around GenAI adoption, which you can see in this chart. And the top consensus is in how organizations need to incorporate their own enterprise data to support GenAI models. Rob, what are your thoughts on these security issues and how to address these concepts for GenAI adoption?
Yeah, the biggest one we hear about is definitely merging sensitive data with LLMs. Back to the use cases that we talked about a little bit earlier. You need data to provide that enriched user experience or to provide the productivity. But then the issue becomes, do the people asking for that information, are they entitled? Do they have access, the correct access control to that data? And are we sure that sensitive information isn't leaking to the wrong individuals? So it's definitely an issue that's top of mind for people.
Mm-hmm. And are these the same application security challenges with an AI spin, or are we dealing with an entirely new challenge here?
It's really both. So when you think about the way that LLMs behave and what some of the attacks against them are, it's a new vector, it's a new category and approach using natural language, which is something that we really haven't seen before. It's in a lot of ways a form of social engineering, but at the same time, there are still a lot of the classic security controls that we can put into place to mitigate a lot of the risks. So it's really a combination of both.
Mm-hmm. And how do you see this with how teams are merging their own data with the applications with LLMs, right? They need to use their own data to make it more effective. So is there a common approach?
Yeah, the most common that we hear about are through the RAG architecture. So RAG stands for Retrieval-Augmented Generation. That is one that users and developers are using across the board. It's really easy to get going with. There are a lot of great examples out there that demonstrate how to bring a wide variety of data stores together with the LLM. But quickly behind RAG are things like an agentic architecture where you're using agents that will autonomously fetch data in real time in response to a prompt. So those are the different categories that we're seeing today.
Yeah, and can you talk about the RAG architecture risks for the audience as well?
Yeah, yeah. So it really first is all about data access controls. So we mentioned this a little bit earlier. When there are users submitting questions to an LLM and external data is being used to provide an enriched response, we need to make sure that that user has the correct access permissions to that file object or to the data or to the vector chunk, whatever it happens to be. We need to make sure that access control is present. Second would also be malware distribution. So making sure that there are not malicious artifacts, files, URLs, domains, or anything like that within that data. So that data needs to be cleansed before it's merged with the LLM or merged with the prompt and being fed back to a user. And then lastly, sensitive data leakage. We need to make sure that the data that's being utilized in a RAG architecture does not contain sensitive information that could be leaked to a user that shouldn't have access to that. And then to wrap all of that together, attribution around all of it is very important. So making sure that we're able to log who submitted the prompt, what data was fetched as part of the prompt response, all of that information is absolutely necessary from an attribution perspective so that security engineers or security professionals can understand how the system is behaving, what data is being utilized, and who it's going back to.
Yes, definitely. So RAG, as you said, stands for Retrieval-Augmented Generation, and it's an architecture as LLMs are trained on public data. But to get the most out of an LLM, you need to train it with that custom data. Sourabh, why do you see that as a popular architecture?
Yeah. So RAG architectures are basically extremely easy to comprehend, build, prototype, deploy, and test. And the architecture really is comprised of like an ingestion pipeline and an inference pipeline, where in case of an ingestion pipeline, the apps are we are connecting to multiple data sources, collecting all the data in one place, and during the inference pipeline, the relevant pieces of information are being pulled from wherever the data has been organized. And this is a concept which is very familiar with to most machine learning people. And so it's extremely trivial for them to get the prototype up and running and prove the value of the generative AI application and interact with the application very very easily. And to add to that, frameworks like LangChain and Llama Index have really made it easy for anybody to overcome any other remaining complications like dealing with multiple file formats or utilizing pre-built classes and these frameworks to carry out most of the tasks that are part of the generative AI application.
Nice. So it makes it very easy to use and adopt. And
Yeah.
what are those end user experience pros and cons of this architecture?
Yeah, I mean, look, I mean, in case of any application, real time changing the data and seeing it reflected into the application really, is the key thing here. Anybody can go about, adding a new document to a document repository if document repository was being pulled as part of the ingestion pipeline, and see how the user's conversation can take advantage of the new information that has been added or some information that has been removed from the data wherever it was being organized. And in order to like cleanse anything, modify anything about the information that is being captured, apply transformations, all of that is really easy to set up in case of an ingestion pipeline.
Mhm.
So those are the kind of pros. I mean, the users can real time see whatever they're changing in terms of information being reflected back to the user in terms of responses. Now, of course, the disadvantage is that these ingestion pipelines are periodically run, so your data that you have pulled into one location can get out of sync or stale compared to the real-time data that is being captured in the original application. And so that's one kind of major disadvantage. And of course, as you get creative around leveraging LLMs, the cost could become quite prohibitive, because the amount of data that's being pulled combined with the user's history can result in many a lot of tokens, and the cost of leveraging an LLM can become quite steep very very quickly.
So it's very powerful, but
Yeah.
how do you manage those RAG security risks?
Yeah, I think Rob already covered, what are the major security risks of the RAG architecture. But I think the biggest concern is, who is the user authenticating to the application, what kind of questions they're asking, and what kind of information they're getting access to, and has the user level authorization being respected throughout the interaction with the application. So the key elements of making sure that the security risks are addressed are making sure there is strong authentication, there is proper authorization enforcement all throughout. And look, one of the other risks that we are introducing with this whole architecture is the fact that we are pulling data from multiple data sources and putting them together in a single repository, which now becomes a new attack target for anybody who's trying to, grab enterprise-specific data or exfiltrate data. So making sure that the security of the new location of the data, where all the data has been put together, is paramount, and making sure that there is no accidental or malicious leakage of sensitive corporate information out of these data stores.
And can you break down the agentic architecture and risks for our audience?
Yeah, I think the agentic architectures are kind of the next level of evolution for generative AI applications, where agents are being used to not just like in time respond to a question, but basically they take a question, they kind of create a plan, they break down the problem statement into multiple subtasks, and they execute these tasks leveraging tools, and so on and so forth. And I think the security risks really are around the fact that these can perform autonomous actions. And so, are they really authorized to use the tools and perform the actions on the applications? And how all of that is going to be, made sure that they're not doing something which is unexpected or beyond the expected security controls. Really, that becomes the huge security risk of agentic architecture.
Yeah. So the AI agents, it sounds like something that's like sci-fi. Is this fantasy or the future? What do you think?
I think agents are here. They are indeed
Mhm.
real, and they are obviously the next level of evolution. Because look, the rack architecture was very much, a point in time interactive. You ask a question, you get a response, and really it is up to the other side of the user to interpret the response and perform subsequent set of questions or tasks. Whereas agentic architecture really take AI applications to the next level, where not only are they able to collect the information, but they're able to process the information, and they are able to act, and they're able to iterate leveraging multiple tools in order to really resolve a use case, and really perform the work, not just provide the information back to the user. So no, it's not fantasy. It's here, and it is the next horizon of generative AI applications.
Nice. And what can agentic frameworks do that RAG cannot?
Yeah, so I mean, as I mentioned, I mean, agentic frameworks are really about executing actions. So not only can they collect information, but they can process the information. They have access to a whole set of tools that might have been provisioned with the application, and be able to invoke these tools in order to perform various things. And they can range everything from like sending emails, creating tickets, resolving incidents, whatever the use case might be. So they are like more complete, and we have seen this in the past, right? Automation really is going to push the boundary of any kind of domain, and here the agents are really pushing the boundary of automation, where they are able to process information, apply the information, and execute actions on behalf of the users.
And what are the pros and cons of this architecture?
Well, I mean, in terms of pros, of course, unlike the RAG architecture here, the agents are able to connect to these apps and pull the information out of these apps in real time. So there is hardly ever a risk of information getting out of sync, because it's all happening real time. And one of the other advantages of the architecture, and this has no comparison to RAG, is the fact that agents can plan around the user's question, and can break down the plans, and can execute multiple actions in order to be more complete and comprehensive. Really are what makes agentic architecture and generative AI using agents really compelling.
Yeah, definitely. And
Yeah.
what about those security risks?
Yeah, I mean, unsupervised action execution is the top of the mind concern, because they're going to be calling upon these tools and passing the information as parameters to these tools, and analyzing the return data, and using it to pass on more parameters to subsequent tools. So there is a lot happening as it is leveraging multiple tools. And so of course the biggest risk remains around the fact that hopefully they are performing the actions that are permitted and authorized and expected, and all the parameters that they're taking are things which are sane and clean, and nothing malicious is going to happen on behalf of these agents.
Yep. So powerful, but make sure you manage those risks. And Rob, how should security professionals be thinking about categorizing AI and the security risks?
Yeah. So the way that we look at it are really through breaking it down to three different categories as far as how an app is constructed. So we have the inference pipeline, which is where the prompt is coming from a user or an application flowing through the app and ultimately intersecting with an LLM. And then we also have an ingestion pipeline. So, on the ingestion pipeline is covering a lot of the things that Sourabh just went through, with data being pulled in through either a RAG or an agentic architecture. And then we also have the notion of authorization controls. This would be the third category, where we have context being fetched from data being merged with prompts, and then the access controls associated with it within those. So those are like three different categories inside of the architecture of an application. But then you can cross section that with different categories of threats or different categories of security concerns that either a security engineer or an app developer may be concerned with. And that starts with things like prompt injection, which is you had covered earlier, but a hotly discussed topic right now. Things like data leakage and content moderation would be a second concern. Third would be attribution, which we spoke to a little bit earlier. Fourth are, of course, access controls on data. And then fifth is controlling agents as they're executing throughout your app. So that's kind of the landscape as we see it in terms of breaking down the categories of an app, and then the intersection with the different security threats and areas that controls need to be put into place for.
Absolutely. And these are constantly evolving as we adopt these new technologies. Let's talk a little bit about OWASP top 10 risks. We've covered some of the related to the previous RAG and agent discussion. But what about threats like excessive agency, attribution, and insecure output handling?
Yeah, so Sourabh made a mention of this earlier with excessive agency specifically, and watching how agents, for example, are going to go off and utilize the tooling that they are going to leverage in order to execute the prompt or the task that they've been given. So ensuring that there's oversight and control over that, and control over what tooling they're able to use, what type of authentication and access control that agent has over those tools are very, very important. Things like insecure output handling are also important. So, what commands can an agent execute against a server or an application is a good example of monitoring or controlling issues with insecure output handling. A second are also the output itself. Does it contain malware? Does it contain pointers to malware? Does that output contain nested prompts that would result in a downstream prompt injection attack? So these are all things that are occurring that an application should have controls for in detecting.
Great. And can you discuss some examples of these AI threats as seen in the wild?
Yeah, absolutely. A great one that I think is definitely referenced in the OWASP top 10 would be indirect prompt injection through a RAG architecture. So things like imagine a scenario where I share a Google document with you, and nested within that document without you even knowing it is a prompt injection attack. So you may not even have opened that document, but by way of that being present in your Google Drive environment, if that environment is also associated with a RAG ingestion pipeline, that prompt injection attack could be processed by an LLM if you do not have the proper controls in place. So that's something that's talked about frequently. And what's scary about that are that it really did not even require interaction from you. If you think about attacks 10 years ago, when you think about things like attachments to an email, it would have required you to physically open that attachment. Well, now with things like prompt injection attacks and LLMs operating on data that you may not even have touched or opened, it opens up a whole other scenario where users may be passing on malicious material without them even knowing it. So the controls are very, very important because it requires less user interaction now than it did before to spread these things.
Wow, yeah. And back to the RAG architecture, can you walk us through the security controls you would implement there to address these risks?
Yeah, so a good architecture is first always going to start with strong authentication. And in this particular case, we want to look at authentication to both users as well as external systems. So when we're authenticating users, we want to always use multi-factor authentication. We want to use passkeys where we can, and even other security checks like checking domains of incoming registrations. Second, on system level authentication, we want to make sure that as we utilize system identities and tokens to authenticate those external applications, that we have strict rotation policies on those tokens and scopes applied to those tokens as well. So these are things that are basic authentication, good hygiene that are necessary for really any application. But as you move deeper past authentication, next comes the guardrail piece. Now, whether it's a user prompt flying into the application or data being ingested through a RAG pipeline, you need guardrails to ensure that things like jailbreak attempts, prompt injection attempts, um, um, malicious content, harmful language, any of those type of potential attacks or harmful content need to be identified in that inference pipeline and or the data pipeline and then cleansed. And that's where guardrails come into play. These guardrails will look at data, they will look at prompts, and look for all of these attacks and ensure that you are either rejecting the prompt, rejecting the data, or cleansing it before it flows into the LLM. And then the last step before all of this hits the LLM is, of course, the merging of the context fetched from data and the prompt itself, but then an authorization check within that to ensure that the context that's been fetched from the external data source is something that the original user has access to per the permission policy of the system. So an authorization check is absolutely critical in this type of architecture. Now, once the context and the prompt come together, we want to apply another guardrail check to that LLM because now we have the complete picture of what's being asked of the LLM. Now, what's great about doing this at this point are that you can catch a wide variety of prompt injection attempts that range from things such as fragmented or concatenated prompts coming together all the way through to indirect prompt injection attempts coming from an external data source. And then once the LLM crafts the response, you can apply another guardrail as that response is flying back to the user. Now, at Pangea, this is something that we live for. We've built services over the last several years that address all of these use cases that go from things like authorization, authentication, as well as token management and rotation in a vault through to guardrails. So looking at prompts, looking for sensitive data, looking for jailbreak attempts, looking for malware, all of those type of things we've made really, really easy for developers or security engineers to stitch into applications via just a single API call.
Yep, absolutely. And Sourabh, what about the agentic architectures? What are the security mitigation strategies there?
Yeah, I think as we mentioned before, agentic architectures are kind of the next level of evolution for generative AI applications beyond RAG architectures that we are seeing. And agents, basically, the key capability of agentic architecture is the ability of the agents to execute autonomous actions. So the key concerns and mitigation strategies are really focused around the fact that, first of all, these agents need to be provisioned with the right level of access tokens, credentials, so that they can perform only the permissible set of actions. The tools are properly provisioned. They are only able to utilize the authorized set of tools that have been given to them as part of their tool chain. And then, anything and everything that these agents are doing in terms of like executing the tools, collecting the results, processing the results, and calling other tools is all being audited correctly so that if it ever comes to the point that you want to question how these agents did what they did, you have a complete proof and audit trail of all the activities that were being performed on behalf of a prompt that came in that caused these agents to take a certain set of actions in a particular order. And then these agents are very well capable of collecting data, ingesting data, and processing data and producing data. And in all that process, we want to make sure that there is nothing malicious, right? I mean, the files that they are consuming are not somehow exploiting the vulnerability that might be there as part of the tool that they're using, or any data that they're processing and producing parameters out of this data is not malicious, as these parameters are being sent to the subsequent tools in order for them to execute subsequent actions. So things like URLs, IP addresses, domains, etc., that are being passed on as parameters, either to tools, or they're being used in order to produce the content or the data for subsequent action execution, are not malicious. Making sure that nothing malicious ends up in the hands of the user are the kind of safeguards that we need to deploy as part of the agentic framework. And Pangea has many services, all the way from file scanning, sanitization, PI redaction, that can all be kind of consumed in various forms all throughout the architecture of an agentic application. And you can apply security guardrails in the right fashion at these right points of the architecture. So those are really the key concerns and mitigation strategies worth considering when building an agentic application.
Great. Thanks so much. Great discussion here. We've covered a lot for the audience here for things that they can be thinking about and kind of map things out. We do have some time for questions, and I see that a few came in. So the first one here, if we encrypt all sensitive data at rest and in transit, do we need these security guardrails? Who wants to take that one?
Yeah, I can start, and then maybe Saurabh can follow up with other thoughts. The answer is yes. You still need the security guardrails. Remember that things like prompt injection attacks can still exist within that. One of the things that we also take a look at with data as it relates to encrypting and ensuring that the system can still operate with LLMs and AI are that using things like format preserving encryption solves the best of both worlds. What's great about using things like format preserving encryption are that you can protect the data as it's flowing through the system. However, you're not breaking the behavior of the system. So if there are things like IP addresses or email addresses or mailing addresses, whatever that sensitive information happens to be, you can encrypt it to something that looks like its original format without giving away the original data itself. So the system will still operate and will still work, but you're maintaining some level of protection against that data. So format preserving encryption is definitely something that we're hearing a lot of users wanting to use when managing sensitive data, whether it's in rest or in flight, passing through system. But back to the original question, guardrails are still absolutely necessary. Things like malicious indicators, pointers to malware, prompt injection attempts can all be present within that data. So guardrails are still necessary.
I mean, the encryption of data at transit and rest does not address how the users are interacting and how they are prompting the application, because at the end of the day, that is where the attack vectors are, not for not at the level of transit or persistence from an encryption point of view.
Yeah, and it's a great question to ask too, because you do have to think proactively about these things and for mitigating risk. Another question here: what's the difference between reback and RBAC? Do you need both to secure AI apps? So we talked
Yeah.
about that access
So
control. Yeah,
Yeah,
Saurabh.
that's a great question. So basically, role-based access control, kind of everybody is familiar with. You
Hmm.
could have roles in enterprises like admin, HR, finance, etc., and you have users mapped to those roles that are authorized to perform certain actions and connect to certain applications. Whereas relationship-based access controls is more fine-grained in the sense that they leverage the hierarchical relationship between the data that might exist. So think of like a Google Drive or a file folder scenario where you have permissions granted to a folder level, which is then inherited by all the documents within it. And if there are folders, it would inherit at the folder level, and files within, and so on and so forth. And you can make exceptions to this inheritance of permissions that is granted to the data as it is organized in a hierarchical structure. And depends on what kind of AI app one is writing. Both have of these authorization models have a role to play, and they both can definitely be leveraged in order to secure AI applications. If your AI application is taking advantage of data that is hierarchical in any form or fashion, relationship-based access control is definitely an added capability on top of just ensuring role-based authorization to the data that is being used in the AI application.
Great. And last question here. If we already shipped AI apps, is it possible to bolt on these security guardrails?
Yeah, I can take that. And again, Sourabh, you can add on. The answer is yes. It is easy to add these guardrails on even after you've built an AI app. The integration is really straightforward. A single line of code, a lot of times, is all it takes if you have the right tooling behind it. And with that single line of code, you can also insert it at really any point that you want within that inference pipeline or data ingestion pipeline, or right before it intersects the LLM as well. And what's great about inserting an API call at that point are that you get the full picture, and that's ultimately what you want. You want the prompt, you want the context coming from external data, all unified together, and then you can pass it through that single API guardrail call before it passes through an LLM, and then the response as well. When that data response comes back, you can also pass that through a single API call to evaluate the response to ensure that, again, things like malicious content, abusive language, anything like that are not included in the response going back to the user. And modern tooling, things like LangChain and LumIndex, Sourabh mentioned already, make it really, really easy to insert these API calls in. So in a matter of literally minutes, a developer could have a very secure AI application prototyped in no time, because these things are so easy to integrate now.
Yeah, and I would also add that like what we are seeing is literally the first generation of generative AI applications. These are not static. Users are just realizing the value of these generative AI applications. They're definitely going to go through an evolution. Multiple architectures are going to merge. It's going to be RAG plus Agentic plus fine tuning of LLMs all coming together. So it is an ever evolving application space. So there's always room for improving upon the security posture of whatever the user has built and shipped. And as Rob mentioned, the APIs are dead simple to add at the respective points in your application architecture. And the beauty of our approach of making these APIs so easy to add, is that you can decide where in the architecture of your application you want to insert them. And depending on the use case and the flow, these APIs are agnostic to the architecture. They are agnostic to the purpose of the application, and they can really help you secure and provide the visibility that you so badly need inside the AI application.
Well, great. There were some more questions that came in, but we're out of time, so we'll have to follow up with you directly for those questions. But Rob and Sourabh, thank you so much for being with me today to discuss this and give the audience some practical tips for setting guardrails and to do risk mitigation for AI applications. It's a great conversation. We know these are areas that are going to continue to evolve. The threats are going to evolve. Please connect with us and follow us. Check out the Pangea site for more information. And thanks everyone for joining us today.